All right, guys, I wanted to go over some of the just brief concepts for review for your test tomorrow. Whether you're in honors or standard, this could be beneficial for you. So go over a couple of the questions that were on the quizzes today, and then a couple of the ones that I just reviewed on the slideshow that I was going through you guys together the last couple of days of class. So I want to talk about domain and range real quick. When you're trying to find the domain and range from a graph, keep in mind that open circle is going to be a parentheses. And a closed circle is going to be brackets, whether it's the right or left side or for the brackets too. With the domain, we're talking about x values, and with range, we're talking about y's. So if you look at this graph here, notice there's an open circle there at -3, and a closed circle down here where x is 1. So again, this is the point 1, -4, and that's included on the graph, and this is an open circle. So the domain, that's the point -3, 0. The domain is going to go from -3 to 1, but it's going to be well, they're both, it's not going to be the one with the bracket, if that makes sense. It's going to have an open circle for at -3 bracket 1. Now, as far as the range goes from -4 all the way till 0. And notice that this point hits 0, so it's not open there. So they're both going to be enclosed in brackets. So it's going to be answer choice A. Domain is x values, range is y values, open circle for parentheses, and closed circle for brackets. So number 2, we have to know how to multiply, add, subtract, divide functions. So I just threw one that was a little bit more challenging for multiplication. Make sure we know how to do that. So you want to be able to add or multiply functions together. So f of x is 3x minus 2. 3x squared minus 2. G of x is x, but there's 2 times it. So it's really times 2x. Don't forget to distribute that into the entire function. So that's going to be 6x cubed minus 4x. So it's going to be that answer choice. Okay, a lot of you struggle with these tables, so let me refresh on what all that means. When it says f -1, that means inverse. And when you're reading from a table, you're looking at this as a y value, not an x value. So I want to look where y is 5. What's my output? It's going to be the x value at 6. So this is going to be 6. The 2 out here doesn't do anything but multiply. It's not going to multiply 3. It's going to multiply by whatever your output here at f of 3 is. So since my f of 3 doesn't have the inverse, I'm going to look at my input value here at 3 and report my output value at 2. So this becomes 6 minus 2 times 2. 6 minus 4, and that's going to equal 2. So your answer in this case would be 2. Okay, we had some struggles with this one too. Anytime that you are making a graph like Skinnier, but you're not actually shifting it up or down, you're not going to do a plus at the end because that's really going up. So we don't want to fall for that trap here. But if we're trying to convert between this graph here to get it to be skinnier, you're going to stretch it vertically. So that's going to be stretched vertically. Not horizontally, stretch vertically. And you stretch vertically by multiplying by some number at the front. To get it to be skinnier and stretch vertically, that number has to be greater than 1. So that's going to be what's going to make this skinnier, the 3. The 1/3 would flatten it. So this is going to be skinnier, aka stretch vertically. And this is going to be, if you put a 1/3 in front of it, it'd be wider. And that would be compressed vertically. So it's going to be this one here. Okay, finding the inverse. I think most of you are here now, but let's just kind of go over the rules for finding inverse. First, you want to go switch the x and the y. So x equals 4y squared plus 7. Then you want to solve for y. So we want to subtract 7 from both sides. So get rid of it over here, make it minus on this side. Then we want to divide by the coefficient in front of the y squared. So that's going to take this 4 off and put it under the x minus 7. When you're finishing that up, you're going to take the square root of both sides. Make sure that the whole fraction gets in the square root, not just the x minus 7. So it's going to be this one. Technically, we should include a plus or minus, but this would not be a one-to-one function because if you graphed it, it would be a parabola. So just keep that in mind later when we talk about one-to-one functions, it'll fail the horizontal line test. So its inverse would only be a function if it were the positive value, x minus 7 over 4, and that's why you see this without the plus or minus. But if you're finding the entire inverse, you want to do the plus or minus. Okay, we also struggle with these graphs. So again, this is going to be inverse. So that means this is going to be a y value. So where is y 4? Well, let's look at the graph here. Y is going to be 4 right at this point. That point is 3, 4. So when my input for the inverse at that y is 4, my output is going to be 3. So f negative 1 of 4, inverse of 4 is going to be 3. If that had said f of 4 without the little negative 1, it would be whatever my value here is in the y spot. And it looks like that's going to be 5. So f of 4 would be 5. But that's not what this is asking for. This is asking for the inverse of f of 4, so it's going to be 3. Okay, so this is more of an honors level question. If you're in standard, you can stick around just to get an idea. It's not hard, but you have to know how to input this into Desmos. So if you're trying to graph this to see if it's invertible, what you're going to do is you're going to go into Desmos and let me open that up real quick. You're going to type in the function f of x equals x squared plus 6x minus 9. Pause the video and see if you can do that first before we move on. Then you can check it afterward. Remember, to get a squared, you can do shift 6. Now, if I want to know if that's invertible, you have to look at what is going to make it past the horizontal line test. And if you look at the vertex of this, when x is negative 3, anything to the right of that, if I hit it, if I put a horizontal line through that, it wouldn't hit this stuff over here on the left side. So you can type that in here by doing a squiggly bracket. That's shift in the bracket sign next to the P. And you can say x is greater than shift period, hit equal, and it would be negative 3. Now when you do that, then you have an invertible function because it passes the horizontal line test. You could also do x is less than or equal to negative 3. But I think this question's answer choice was greater than or equal. You can also access those inequality symbols by going down here and seeing them down there as well. So going back at the question, the answer would be x is greater than or equal to negative 3 because that's where that vertex lies. Another one, this one's kind of hard to see, but it says, how are the functions transformed? F of x is the red function, and g of x is the blue. And it does go left and down. Well, it goes left 4 and down 3. Now, if I'm going left 4, then I want to add 4 in the parentheses. And then the minus 3 at the end would be down 3. So left and right are always the opposite signs of what you see on the coordinate plane. If it's going right 4, it's going to be minus 4. That would be right 4 and down 3. This would be left 3 and down 4. And this would be right 3 and down 4. So this is the one you want to pick because it's left 4 and down 3. And again, more of an honors level question, but if you're standard, this is, again, fairly simple. When you do composition of functions, you want to make sure that they, when you put them together, and I'll just give you a real quick example. Let's say f of x is x minus 5, and g of x is x plus 5. If I plug one function into the other, so let's say if I do x plus 5, and I replace the x value here with that, then that's going to look like this. Which, by the way, this would be f of g of x. It would look like x plus 5 minus 5. Those 5s are going to cancel out, and you're just going to get x. And if I reverse it, I did g of f of x. That's going to be the other way. So it would be like saying x minus 5 gets plugged in for this x here. So x minus 5, and then I add 5, and in both cases, those 5s are going to cancel out, so that's going to give me x. That's how you know they're inverse of each other, because remember, they reflect over the line y equals x. So if you're getting both ways of composition to give you x, then that's going to tell you that they're inverses. So that was the major ones on the quizzes we had problems with. Now let's talk about just recapping some of the harder ones on the review we went over together. So this is talking about range of the function. Range is the y values. And if you look at the lowest number, it looks like it's a little bit below 2. So negative 2.25 is an appropriate number down here. And then it does include that number. So you want to use a bracket because it does hit it. Now it goes as high as 4. And again, it includes that number. So 4 is the upper end. So it's going to go from negative 2.25 to 4. Both are going to be brackets. Now you take that same graph and you ask for a domain. Well, domain's the x values. Well, that's going to go from negative 1, and it includes that. But notice that the 3 here is open, so it does not include the 3. So it's going to be this first option. And then you'll have questions talking about, is it 1 to 1? No, fails the horizontal line test. HLT, horizontal line test. To recap, again, more just going over the restrictions for domain to make it invertible. You can use squiggly brackets in Desmos to see what's going on. So for this one here, if I want to graph the function x squared plus 4x plus 4 and see which one of these restrictions is going to make it invertible, I can do that. You might be able to guess too by looking at the vertex, but if you look at the vertex, notice that it's bottoming it out at negative 2, 0. So if you look at that x value and I say, if I do shift the bracket and I do, let's say x is greater than or equal to negative 2, that'll make it invertible because it passes the horizontal line test. And I could also use less than or equal to negative 2. Either way. So if I'm looking at my answer choices, in this case, it's going to be B because let's say I did negative 4. Oops, that was greater than. So if it was greater than or equal to negative 4, notice that it would fail the horizontal line test here because it goes back up again. So you didn't want to use that. If it was less than or equal to negative 1, it would fail it again because, again, this kind of comes up here, fails the horizontal line test. And then finally, the last one, if it was less than or equal to 0. Same deal. It fails the horizontal line test. So the only one that works in this case is greater than or equal to -2, or if it was the other way around, less than or equal to -2, that would be fine too. Okay, this is another one that's just talking about which restriction is the inverse not a function. Just look at the graph here. You know, we don't have the function to graph, but if you look at between 2 and 3, and you might see this as 2 to 3 if it's in this notation. Between those two numbers, if that's the only part graphed, the inverse is going to be a function because it passes the horizontal line test. So that's good, right? If it's between 3 and infinity, that would be here to there forever. And of course, that passes the horizontal line test, so that's good. If it's between -infinity and +1, then it's going from the left up until it gets here. Again, that passes the horizontal line test. You can throw a horizontal line in there and the inverse will be a function. So it's good, which means that the last answered choice is going to be your the one that doesn't work. So if I go between 2 and 9, and if I look at 2 here up until it hits 9, well, you're going to see that right there, it fails the horizontal line test. So these three are good, but that one is not good because it fails the horizontal line test. So it's not going to be invertible on that domain. And then the last one on here, and again, this is more of an honors level question, but if you're standard, I encourage you to challenge yourself. I had a typo on this earlier, so I did fix it. If I want to graph this and it's restricted to a certain domain, that means if it's -infinity to 1, you'd say x is less than 1 in squiggly brackets. If it's 1 to infinity, it's x is greater than 1. So we can actually put this into Desmos too. So open up Desmos, take a minute, pause the video, type that in, and even put the squiggly brackets x is less than 1, and I can show you what to do with that. X minus 1 squared plus 2. Now you'll notice that if I don't do the squiggly brackets, it won't be 1 to 1. But if I say x is less than 1, you'll see an invertible graph. And now we're going to look at this, and let me go ahead and let me do a screenshot so it's easier for me. Let's take a look at that function. I do not want my face in there, so hold on. Let's do a screenshot. So this is what that function is. Now, which one represents the inverse of that function? Well, remember, inverses are reflected over the line y equals x. So if you look at this point, the line y equals x is diagonal. It's not going to be this one because that's more of a vertical reflection. If you look at this point here, which is at 1, I believe 2, we would expect the point 2, 1 to exist on our inverse. Well, this point 1, 2 is here, so that's not going to be it. This point's -2, -1. That's not going to be it. This point's 1, 2, which is actually this graph here. But this point is 2, 1. So that's the one that's actually going to represent that portion of it. So I'll kind of show you on the graph here. This one's a little trickier to enter in. I don't expect you guys to know the ins and outs of entering this in yet, but it's basically going to look like this. I'm going to change this to y for a second. If you just switch the x and the y, you'll get the inverse graph, but it won't be a function. It's this portion here down, okay? Because if I did the line y equals x, that'll split it right in half. Now, if I want to get fancy and eliminate that upper portion, here's what you can do. subtract the 2 from both sides. Take the negative square root, negative SQRT, because that'll get the bottom part of it. If it was the positive square root, it would be the upper part. And you see how it just highlighted that blue portion. So if I hide this here, well, let me solve it for y and get the whole picture here. SQRT, x minus 2. If I add 1 outside the square root and solve it for y, and I hide that, now you have your 2 functions, and they do reflect over the line y equals x. That one's tricky, but hopefully that makes sense seeing it. Do I expect you to know how to input all that? Yeah, no, I mean, if you figure it out, great. But just knowing the patterns here and how to look for it is going to help you out. So that concludes the review, just kind of recap of what we went over in the last couple days of class. I hope that's helpful to refresh and review for your test on Friday the 28th. So good luck to you guys, and hope this was useful for you. Take care.